Hello, algebra students. Welcome back. Today's lesson is on choosing the most efficient way to solve a quadratic equation. There are three methods of solving quadratic equations. The first method we learned was the factoring method. Okay. The second one was the square root method. Now you have to remember the only time you can use the square root method is when there is no bx term. Okay. And the last one was a quadratic formula. Now it seems like everybody likes the quadratic formula because it's one way, just do it this way, not much thinking involved. But it isn't always the most efficient way. So one thing we like to do is be able to look at problems and determine which way is the most efficient way to solve quadratic equations. So in example 1 here, we have negative x squared plus 8 equals 7x. As soon as we see any x term in a problem, that tells you cannot use the square root method. Okay, so we're down to two other methods, the factoring method and quadratic formula. Well, if you remember, the first step in solving quadratics is always to set the quadratic equal to 0. Now, generally, a lot of us would say, okay, to set this equal to 0, I would subtract 7x. But life is much easier when that leading coefficient, or the x squared term, is positive. So what we're going to do here is we are going to add x squared to both sides, and then to get rid of the 8, we would subtract the 8. Now, when we rewrite this polynomial, we want to write it in standard form. These eliminate, and this left side becomes 0. But when we write our polynomial, we're going to get x squared, since it's positive. 7x is positive, so we're going to add it. And that 8 is negative, so we're going to subtract it. Okay? So now, our polynomial is in standard form, written as x squared plus 7x minus 8. Well, quadratic formula is, not hard, but it could be time consuming. So looking at this, first thing I'm going to do is look to see if it's factorable. You don't even have to use AC method. Do we know any numbers that multiply to give us negative 8 and add up to positive 7? Well, if I look, 8 times negative 1 and 8 plus negative 1 make that happen. So this is factorable. So we would go ahead, factor it. But if you remember the factoring method, we're not done here. We got to go and set each factor equal to 0. And x equals negative 8, x equals positive 1. Okay, since it was an easy factoring problem, the factoring method is the most efficient way to solve that problem. Alright, number 2, when I look at x squared equals 25, I know right away that there's no bx term, there's just an x squared term, and a constant. If there's no bx term, alright, I'm going to use the square root method. And in the square root method, remember, you don't set it equal to 0. You basically get x squared by itself, which it is already. You take the square root of both sides. But do not forget, once you take the square root of both sides, you have two possible roots. And the square root of 25 is 5. So your answers would be positive 5 and negative 5, which is how and we represent that using the plus or minus sign. Number 3, okay, when I look at this example is already set equal to 0. I have an x squared term, I have a bx term, and I have a constant, which means square root method is not possible. So the next thing I look at, this is a problem we should be able to look at and determine if it's factorable right away. So I say, are there any numbers that multiply to give me negative 30 and add up to negative 7? Okay. Thinking about that, negative 10 times 3, does that make both of these happy? Yes. So it is factorable. So it is the easiest method to use. Okay. So once I factor it, I set each factor equal to 0, Okay, and x equals positive 10, x equals negative 3. Now, number 4. That problem set equal to 0. We have an x squared term, we have an x term, and we have a constant. Again, square root method, not possible. But if we were to factor this, we would have to factor this using the AC method. So let's check to see if the AC method works right away. A times C is going to be 2 times 1. We need to find the numbers that multiply to give me 2 and add up to negative 12. Alright, what numbers make that happy? There are none. So the factoring method is not even possible here because this polynomial is not factorable. So there's only one method we can use, and that is the quadratic formula. Now when we use the quadratic formula, we find A, we find B, and we find C, and we evaluate the discriminant. Okay, so negative 12 squared minus 4 times 2 times 1 gives us a discriminant of 136. Once I know the discriminant, I know I'm going to have two solutions here. So right away, x equals, if b is negative 12, the opposite of 12, negative 12 is positive 12, plus or minus the square root of 136, all over 2 times 2. And now we can go and find our two solutions. X equals 12 plus the square root of 136 over 4. And then the other one would be x equals 12 minus the square root of 136 all over 4. These are two evaluations you want to do in your calculator. And when you add and divide by 4 up top, you get x equals 5.92. When you subtract and divide by 2, you get a value of 0.08. Thank you for your time. Now you try problems on your own. Thank you.